right, guys, and our last video on exponential growth and decay is on rewriting your exponential functions in different formats. So previously in the first one, we learned what your basic exponential function and growth and decay functions looked like. We then looked at the models in the second one, the growth and decay models. And now we're going to look at, well, how can I rewrite one in the other to find a decay rate or a growth rate or something to that effect. Okay, so again, just a quick review of what the models look like. It's y equals a, some initial value, 1 plus r, 1 plus your rate, or 1 minus r if it's a decay, to some time, to some t value. Okay, so in order to rewrite it, I'm going to move myself up here. In order to rewrite our models, we're going to start with a basic growth or a basic decay model. And first, you kind of want to decide, is it growth or decay? So you know if you're looking at 1 plus r or 1 minus r. And then from there, what often is happening is your exponent isn't just a basic t. If it was, then we know we can easily find the rate by doing 1 plus r equals the value or 1 minus r. But that's not the case when we have an exponent with another value, with a variable and a constant attached, right? So in this case, what we want to do is actually separate the t, your exponent, from its coefficient. It might be something as simple as just literally pulling them apart, or if you have your fractional one, just know that it's going to be a fraction times the variable. All right, so the first thing you do is pull it apart. So t over 3 is really 1/3 times t. I want to pull it apart, so now I can put the 1/3, I can put the coefficient with the growth value, and I can keep the time and my variable exponent by itself. So you can see how I did the split here. Then take out your calculator. You're going to figure out what is the base to that new exponent. So 4 to the 1/3 came out to 1.5874. We're going to round to 4 decimal places. It's going to keep us nice and neat and easier to work with. And then from there, I can figure out what the rate is. I can do 1 plus r if it's a growth equals that new base, or 1 minus r equals that new base. And then I can easily get the rate from there, write it in the growth or the decay model, and come up with the rate if they ask. And they might ask, well, what is that rate? Okay, so it's a matter of pulling apart your exponent, putting the value, the coefficient with the value with your base, reevaluating it, and then setting it equal to 1 plus r or 1 minus r. And I gave you two examples. So the first one we looked at was a growth one. The second one is a decay one, 0.2, obviously less than 1. So it's a decay. 3t, obviously easy. One's 3, one's t. These 3, the coefficient goes inside with the 0.2. Put it in my calculator. I had 0.008. Yes, I only did 3 that one time because there was nothing after the 8. And then I solved for r. Okay, so I'm going to do just maybe 1 or 2 examples with you as we go through this, since a lot of these will be done in class, and this is just talking about the steps in general. Okay, so I'm actually going to do this last slide. I'm not going to do the whole thing. Maybe I'll do the first and the last one there, just so you have an example. All right, so first thing I'm going to do, take my exponent, t over 2. I'm going to split it. That becomes 1/2 times t. Okay, make sure you take them apart. That 1/2, now I'm going to rewrite my equation. The a is just going to stay there the whole time. We're going to get 3 to the 1/2. And then the t's on the outside. You're then going to simply put 3 to the 1/2 power in your calculator. Okay, that's going to come out to be 1.7, actually 1.73, I believe. 1.7321. Oops. To the t power. Okay, again, this is a growth function, so I can then take that inside set it equal to 1 plus r because it was a growth. It's bigger than 1. And we know how to solve for r. Just simply subtract. And you get 0.73. Oops. To 1. Okay. And then again, we can rewrite it if need be. 1 plus 0.7321 to the t. And it says state the growth or decay rate. This is a growth rate of 73.21%. Okay. So let's talk about 15. And then we'll be done. All right. So again, first thing I'm going to do, take the 3t and split it. So it's 3 times t. Excuse me. Easy enough there. So I'm going to rewrite 0.4 to the third power. And the t will be on the outside. Again, I'm going to put this in my calculator. And that gets me y equals a 0.064. There is nothing after that. To the t power. It's less than 1, so it is a decay. So when I set this equal, I'm going to set it to 1 minus r. Same thing. I'm going to subtract the 1 and then divide by a -1. So I get 0.936. And again, from there, I can rewrite the equation y equals a 1 minus 0.936 to the t. And again, this is a decay rate of 93.6%. Okay, and that's what we're going to be working on throughout this lesson.